Okay, so we're going to be looking at the second session here in Module 4. And as we go over here, we're going to notice that we're going to be looking at auxiliary views. So the first thing we're going to do is we're going to open up our PowerPoint here. I'm going to zoom out just a little bit so we can see this. But this is going to be Chapter 9 from your Gajewski Technical Drafting textbook, okay? Now, the objectives here is really just to kind of, introduce us to what auxiliary views are and why they're used, and then a little bit about how to generate them. But the practice of generating them and creating them is going to be through the practice that we get in the AutoCAD portion. Okay. So first of all, an auxiliary view. An auxiliary view is going to be an additional view, something outside of the principal view that is going to give us information about a part that we wouldn't be able to get from the principal views. Now, as we had talked about with section views, sometimes it's because the features we're trying to dimension to or to see are maybe internal, so we have to cut through the part to actually see them. But in this case, we're not making cuts, we're actually looking at it in a different direction. So for instance, if we look at this part here and we would do a traditional front view, okay, we would get a skewed view of this top portion. If we look at it from the right side, we would get another skewed view because unfortunately it's not, square to that, if you would. And top view wouldn't give us enough information either. So what we end up doing, you'll kind of see it here, is we end up looking straight on or perpendicular to that surface so that we now can see what we say is the true size and shape of a feature that we're seeing here. And most specifically, it's going to be the outside radius as well as the hole that is on the inside here. When we get to dimensioning, we're going to find out one of the rules is that we cannot dimension, number one, to a hidden feature, and number two, to an item that is not its true size and shape. So if we're dimensioning, for instance, to a hole, it has to be where we see it as a circle, as an object line. We could not, if we would show this going from the front view here, we're going to be seeing an example when we do our AutoCAD work a little bit later. It would be an elliptical looking shape. It's not going to be a true circle. So we cannot dimension to that. Okay, so we're kind of setting you up with these section views and auxiliary views so that as we then add the dimensions and the sizes and the notes to our drawings to complete them so somebody can make them, we're also able to create these extra views when needed. Okay, so auxiliary view is to create an extra view that is not one of our principal views, top, front, left, right, bottom, back, whatever they all are. And there's 6 of them. And instead we have to create something that is going to be, if you would, special to be able to see a feature or more that that will then be able to be dimensioned to as we see here. Okay. So when we have an auxiliary view, we need to kind of set up how we're going to look at this. And in here it says an auxiliary plane. Just like we did with the glass box around our part when we were looking at primary views, we're now setting up an extra side, if you would, that is at a different angle as opposed to just 90 mutually perpendicular sides of like a box or a cube. So here you're going to notice that we set up our surface so that our line of sight will look perpendicular to the surface in this case that we want to look at. Okay. Many times we want to see the true size and shape of something. And I already mentioned the dimensioning side of something, but maybe we also want to determine how much square, surface there is there. Okay. Or area that there might be. And the only way to do that is to see the shape as its true, in this case, rectangular view. If I look with a right side view here, this would be foreshortened, okay? Because one surface is back further than the other. The only way I can look at it and get its true size is to look perpendicular to it, okay? So, so you'll kind of see here then that we unfold just like we do the other sides of our box, our traditional box for our traditional views, but it's going to then have a hinge, if you would, that would be parallel to the surface in this case that we're wanting to look at. Okay. So just a little bit different view there. As we look here, primary auxiliary view. A primary auxiliary view is an auxiliary view that comes off one of our primary views. So it's going to be in addition to, or comes from, originates from a front, a right side, a top, or any one of the principal views. We can make secondary auxiliary views. We're not going to go there, okay? But one will be good for the practice that we're gonna need in the parts that we're gonna be looking at. Here it says hidden lines and auxiliary views. This is going to be a judgment call. This isn't a hard and fast rule. It's kind of, it's in section view, it's hard and fast. We put no hidden lines in section views, but in auxiliary views, if there aren't a lot of lines, and I'm going to have you guys add them because our parts aren't that complex. If there aren't a lot of lines, you just want to add them because then it adds clarity to the view that you have. But if there are a ton that don't really serve a purpose, or you feel like it's making it look cluttered or even more confusing, then it's okay to omit them, okay? So auxiliary views are kind of a judgment call that way. We're going to find out assemblies are that way too. You know, you kind of look on the side of no hidden lines, but then if there aren't too many, why not add them in? Because it just completes the view then. So that's how I look at it, and you're going to be adding them. Again, it's good practice. Here we can have views, and we can use arrowheads to show the direction that we're looking in, just like section views. When we put the arrows for the direction of the view for our section view, the arrows are telling us which way we're looking. That's our line of sight. Okay, so in this case, you're going to notice that we have these lines. Now, they're not cutting through material. They're there to help us understand what is the direction of the line of sight, and that's what the arrows are doing for us. They are looking perpendicular to this surface right here, that if we look straight up in our top view, we see that as a skewed surface or an elliptical shape on the hole and on the arc of the outside. If we look on the right side, we have that very same view. The only way that we can get the true size and shape of that arc over the top, or that arch over the top, and the circle that's going through is by looking perpendicular to it. So these, I'm not going to call them cutting plane lines, because in this case, they're not cutting through any material, but it's the same type of line work that we would look at, but the arrows are showing us which way we're looking. So for section views as well as auxiliary views, those arrows are telling us what is our line of sight, okay? And then the view is going to be in back of it, just like it would be for a section view. The difference between where we put these views, though, is that our auxiliary view has to be in projection, okay? They have to be in projection. You cannot take an auxiliary view out of projection. Section views you can, but auxiliary views you cannot. All right, they have to be in line. Okay. And I think that's my last slide. So yeah, it's a nice little short and sweet little lecture here, just kind of giving us the basics of what an auxiliary view is, when we would use it. And now we're going to get our practice through an AutoCAD example.